Good morning, good afternoon, good evening, everybody.
Hello.
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 Mohammed, I'm glad you're here. You're the star of the day, I guess.
Yeah, thanks.
I'll give it a couple more minutes, see who the stragglers are coming in.
Sure.
All right, 3 minutes after the hour, and time goes quickly in these meetings, so I think it makes sense to get going. We're missing a few of the regulars, I think, but perhaps they're not making it this week, or perhaps they're just gonna show up in a few minutes. So today's topic is Mohammed, who I know has a proposal for a project for this SIG. And I believe it's been, historically, Mohammed has, presented a handful of presentations to the SIG, and as best as I can tell from reading through the information there, this seems to be kind of a continuing refinement and of those accumulated ideas and places you want to take the activities, the resource, the code, and so forth. Mohammed, do you want to take it away and kind of give us an overview presentation from your perspective on what the proposal is and why you think it makes sense for this SIG to adopt it?
Sure. Yeah. So I have actually, so my idea basically was that everybody has a look. So I have actually not an overview slide, so it's kind of an accumulation of everything. So, but if you like, I actually wanted, to say that I actually wanted to cover what questions comes up. So Thomas had some questions, I clarified them, and we defined the proposal accordingly.
I suspect it might make sense to briefly recap the proposal. I've gone through the information myself.
Mm-hmm.
I read it, I've read it all, but it's been back a few weeks. So some of it's, I understood it in detail, but better about 2.5 weeks ago than now. And it would also be good for me to kind of hear from your perspective, the kind of the elevator pitch of what this is about and so on. So maybe a 5 or 10 minute kind of recap of kind of the overall, and then maybe perhaps the Q&A session, like I think you're envisioning. Does that sound reasonable?
Right. Yeah. That's fine. So I can start with the basically I have written down the same goals. As I said, I have like 70 slides, which is kind of an accumulation of all, so that whatever question comes up, I can precisely answer that. So let me start with the goals basically, and slightly touch upon or hand wave through the approach of what this is, and then this is kind of more in depth. So I will only describe, maybe quickly go through one of them, which I already presented in one of the CCC SIG meetings, and kind of overview the related work in a few minutes. So that would be my suggestion or program. Okay, so the goal of the proposed thing is to basically have the first goal, so to say, the high level goal. So I have divided into two main goals. The first one, basically, idea is to have a refinement of the attestation architecture for confidential computing. And what I mean by attestation architecture is basically the RATS architecture, which already exists, has its own vocabulary and everything. And by refinement, precisely, I mean, from very practical usage perspective, it exists, it has been accepted as a standard, but somehow I think there is still a lot of room from the practical perspective of what exists in the confidential computing domain specifically. So the target there is specifically this confidential computing, not about TPM, only its connection to the confidential computing. For instance, if in connection, when it's used in connection with the trusted execution environments. So that would be really the focus of the thing, excluding all other use cases. Attestation is used a lot everywhere, so we don't want to focus on that. And as per the regulations, so the coding part here would be the formal specification and analysis of all phases of attestation mechanism in a tool called ProVerif, which was already presented in one of the meetings. What I specifically mean by all phases, I will describe in a couple of slides, what phases we envision. And it might be that we also need some other tools. So this is not the only tool, this is one of the suitable tools that we have. And dividing it down into sub-goals, what exactly this means or what could be pursued in the scope of this specific proposal is, first of all, as I said, the refinements, and refinements also include the precise definitions of the terminology. For instance, one of the discussions in last meetings was what exactly is the difference between an endorsement and what was the other thing I forgot, the reference values, right? So what exactly or what precisely distinguishes the two things? So we need to go more towards precise definitions or formal definitions as far as we can, so that everything is precisely clear, and then one can really talk about the terminology in the scope of confidential computing. Another sub-goal, so to say, is once we have an overall standard architecture with the precise definitions, one can then categorize all the existing solutions into three major groups. In one of the slides, I will describe what these groups are. And once we have these groups, we would like to instantiate all the existing solutions in one of these groups. And why I say specifically two prominent solutions, the reason for that is that once we would like to have some variety, first of all, in the solutions. Not all solutions are using the same. For instance, the IPM PEF solution uses a very different approach as compared to Intel SGX, for instance. I will talk about it more when I go to the categorization where we have. So to say, the reason for two prominent solution is to cover wider range of the solutions, and then to, I think it's one of the goals, yes, so that we can scientifically compare and contrast what are the trade-offs within the solutions in each category or in each group. So
hey,
this is
Mohammed, excuse me for interrupting. Just
Sure,
a process question. I see Keith has his hand up, and I know we planned a Q&A kind of after the overview.
No, I would like that if there is a question in between, please go ahead. I would like it more to be like kind of discussion. So
okay,
please go ahead.
And the word refinement is a bit imprecise itself. I'm curious what you mean here. Like we have in this group talked a lot about using RATS terminology for the different aspects of attestation. Is the comment here that that the RATS terminology is not precise enough, or that we need to map concepts in things like S&P and TDX to RATS in a clear way?
I would say both. So and they are both interdependent. Let's take an example of NETE, so to say. One thing is that in order to map, we need to know what exactly, let's say, endorsement is, right? So that's why I say that it's kind of interrelated. And the other way around, if it's precisely defined, I can then precisely map it to a standard architecture. And my claim, therefore, is that basically neither the terminology nor the architecture itself suffices for the precise mapping of confidential computing use cases. I'm not talking about others. It might be nice for, let's say, for TPM and so on, but for confidential computing use cases specifically, it includes both. Does that answer your question? Or
I think somewhat. You might get into it more later though, but
yeah.
The specifics on what isn't currently precise enough, I think at some point will need to be clarified.
Yeah, I think I do have a slide on that. Let me quickly see if
I mean, if you plan to get to it, we can get to it at that point. But
okay, sure. If that doesn't answer your question, please go ahead again.
If we're going to clarify what is meant to be more precise, then I'm happy to wait for that.
Yeah. So we have already. Yeah. Sorry, Greg.
I was gonna. The way I'm interpreting this is we're gonna. The proposal includes doing some detailed prototyping, coding, proof verification on specifically confidential compute scenarios, and part of that work probably is going to show where perhaps there's some holes in the RATS architecture doc, or perhaps there's some things that can be more clearly defined given a more scoped set of attestation scenarios being confidential compute versus just anything. But if that's correct, then what is your intent with whatever we kind of learn there to feed that back to the RATS architecture document and say, hey, here's some suggested changes? Or is it, where do these refinements, get routed to? It seems like the most valuable place would be, essentially a RATS RATS architecture doc v2 or what have you, or update that includes some of this feedback. Or did you have something else in mind?
And if I might, before you answer that, I think my general thoughts on a few parts of this proposal is that it's very hard to kind of envision what success would be here. And if we had more statements on what would constitute a success in meeting these goals, it could help.
Right. So to answer the first question, I would say these refinements can be easily integrated into the RATS architecture. So let's say a newer version or an updated version of that. So that's not a problem. For instance, specifically, let's say the RATS architecture specifically talks about remote attestation only, and local attestation is considered out of scope for that. So that was one of my discussion with one of the authors. And so in order to model the real world scenarios like Intel SGX and Intel TTX, one needs to have local attestation in order to model the remote attestation. It's an essential part of remote attestation. So one cannot really talk about remote attestation alone. And that is the kind of thing that we derive from the real world scenarios, or we see from the real world scenarios and have it in the RATS architecture, for instance. That would be one possibility. I don't see any kind of problem in that. Other than that, for instance, let's say, I think I have an example on that. We added some provisioning module to that, and I can describe it in one of the later slides. So the feedback part, I do not see any problem in that. That can be easily fed back to the RATS architecture. In fact, we have one of the errata already to the authors. I don't know what the procedure is. I'm not very familiar with the procedures there, but I can surely say that we will be happy to continue this and feed it back to the RATS architecture.
All right, cool. Thank you for that explanation.
Yeah, welcome. Okay. So should I continue, or was there any other comment on?
Well, Keith had asked about indications of success, like what does success look like?
Yes. So let's say success would look like, for instance, if I can nicely map, let's say, the existing technologies, and we are taking two of them. So, and as I said, it's covering a wide range, right? So what really distinguishes not the similar ones, for instance, Intel SGX and TDX are quite similar. So taking the different one, so once we are covering a wide range and they can still be mapped, there is a high guarantee that the attestation architecture is quite generic enough. So I would say one criteria of success would be that the architecture and its terminology is good enough so that two different kind of architectures can be easily mapped to the generic architecture. But by architecture, I need to rephrase that. I mean, two different trusted execution environments can be mapped to the same attestation architecture. I would call that one of the success criteria, that the attestation architecture is good enough that it can map a wide range. And for instance, let's say for Scone and one other architecture, let's say for Google Oak or something like that, which are based on different things, and then if they can both be mapped satisfactorily, so I would say that the attestation architecture is clean enough and clear enough so that one can understand. So that would be one of the examples of what it would be, what success criteria would be, that in my mind. Of course, when we work more on it, so these pointers or things will be more clear on the way.
So is part of this proposal then that this group, as the attestation said, create such a mapping for a variety of environments, or not?
Yes, so we already have for each of the categories. Maybe I go to jump to one of the slides where I have actually. So this is the three groups that I mentioned, and this is a joint work with Thomas and Simon. So the categories are that we have, let's say, the vendor solutions, which includes these trusted execution environments, SGX, TDX, AMD, SAV, SNP, IPM, PF, and so on. And secondly, the architecture lead solutions, which on the basis of which one can build its own solution, like ARM, CCA, and RISC-V trusted execution environments. So this category includes these kind of solutions.
Where
And
would Amber fall on this Venn diagram?
So I'm not very much familiar with Amber. So is it not a complete solution of?
It's Intel's attestation for Intel's hardware.
It's an attestation verifier. It's not a trusted execution environment.
And to be clear, there's multiple examples. There's like Verizon, there's the Microsoft Azure Attestation Service, there's Amber, and et cetera. And there's,
Right. So these are basically covering part of the solution and not complete solutions. So they can be combined with other solutions, right? So Microsoft Azure Attestation, for instance, and so on.
I guess a confusing part here is Intel SGX is not if we're thinking complete solutions supporting end-to-end through relying parties doing, completing their scenarios. Intel SGX is not complete, and neither is Amber.
Yeah.
So it's maybe that's part of the confusion here.
Right. So basically, if you think in terms of that, so basically, yeah. So it's offering the base solution, but it has its own attestation mechanism, so to say, right? But correct me if I'm wrong. So Amber will be building upon SGX, right?
I think Amber is a verification service, right? That's I shouldn't speak for
but for which trusted execution environment, so to say, is it supported?
Theoretically, any.
Yeah.
I wonder if one of the differences here is that this slide is from the perspective of attestation generation. And then these other things are really more verification focused, but both kind of probably bleed on each other.
Right. I have to think a little. So if you have attestation generation, so that will already be done by only the two categories. I mean, then we do not need the framework category to build the solution. I mean, Scone is building upon, let's say, Intel SGX for now. It might be in the future that we have AMD SAV, we have Intel TDX and so on. Grameen similarly is building upon Intel SGX. So if we take creation or the generation of attestation evidence, then we need some different categories. Like there will be only two different kind of solutions, so to say.
Yeah, so maybe we don't resolve that today, but this at least gives us some idea where you were thinking.
Right. So yeah. Okay. So let me go back to. Okay. So I think I was describing this, that once we have two solutions, one can compare within each group the different trade-offs of these solutions and compare and contrast which one is suitable for which specific kind of use case, and so on. So this is one of the use cases, one of the simplest ones. So we can then otherwise also compare different things. And the coding part in this, as I said, is the specification and analysis of the different phases that I showed in one of the slides. I will show again in more detail that we have divided into 4 different phases. And the coding part includes basically the 3 of them: initialization, attestation protocol, and provisioning phase. The 4th one is basically the trustworthy operations that one can do as per requirement of the use case. So this was what constitutes the first goal.
So
just
before we move on from the first
Mhm.
goal, then, so this is talking about formal specification analysis of the attestation protocol, but like what protocol? Because we have the attestation evidence that can be tied into any protocol. Like it could be like we have the effort spun up on creating secure like TLS sessions using attestation evidence. That would be one example of an attestation based protocol, but it wouldn't be the only one.
Right. So I'm not sure about the question. So are you asking that we will cover all of them or one of them?
Well, I'm asking what
it...
you're proposing. Like when you're saying that we need a formal specification analysis of attestation protocol phases, like what attestation protocol is in scope? Okay, so the scope is basically these 3 major categories, and the scope is 2 prominent solutions for which we have what we already have is for this vendor solutions, Intel TDX. Architecture lead solutions, we have ARM CCA, and for frameworks, we have Scone. So attestation protocol will mean what this category actually implements, or what the TE basically. Categories implement a way to generate attestation evidence. And that can, and then also how to verify that evidence. Like there's those 2 pieces, but there's a protocol, and you can include those 2 pieces in any number of protocols. I don't know if like what you envision as being the modeled protocol. Like let's just take the first one on the slide for Intel SGX. What protocol would you be verifying is using the attestation evidence correctly? So for Intel SGX, if you talk about that specifically, so there are two protocols, APID based and decap based. So one can formalize, or actually we have already verified not in the context of RATS architecture, but we have generally verified these protocols separately.
Can I jump in here with a comment? Because I think since Mohammed tying these classifications to actual architectures, then perhaps the attestation in your context, Mohammed, is what is architecturally defined as attestation. Anything else that can be built upon in a custom manner by a cloud provider or by a framework provider, it doesn't seem to me is what this formal verification work is targeting. So this is more about the architecturally defined Intel SGX remote attestation. Like you would verify how the quality link claim interacts, perhaps how does it get the key, what are the trust assumptions around that, stuff like this. But I might be off.
No,
So-
that's
so if-
actually correct. That's actually correct. But this category, let me add a small comment, Keith, and then I will come back to you. So just to clarify, so this category, what you're saying is correct in these two categories, that what they actually provide. And for this category, there will be an additional that what the complete solution, because this is a complete framework, right? So this is building on top of that, and that includes probably what Keith is thinking about, that is how the TLS and all these protocols are working together.
Right.
So
this
if I could
category-
paraphrase a bit, then what is in scope here? Like, let's put aside the frameworks for a second. Would be just that how a relying party would verify the attestation evidence. Not how that attestation evidence is tied to any particular higher level protocol.
Right, that's correct. So that
Okay.
To correct the first part, it will not only contain the verification part, but also the generation part. That is, if we talk about Intel SGX, it will not only be the relying party. So if we talk about the relying party, so the relying party is only getting one signed thing, right? So the verification is not very interesting there, so to say. The focus is for these two is basically how the evidence is generated, what are the assumptions there, what can we trust the hardware to do, and what are the trust assumptions there. So I would say the verification as well as the generation would be the focus. And the second part, you're correct that it's not tied to any specific protocol. One can build on top of that. So that's why it's kind of not included in these two categories.
This is super useful. I'm new to the group, by the way, so maybe I should say hello. Islar from Canonical. And this attestation, your question here has always confused me a bit. And I find myself talking to people and it seems that we're talking about different things. So let's say we have enabled AMD Sieve on Ubuntu 20.4. There is one first level of attestation which has been defined by AMD, and it is tied to the actual, how is it called, the coprocessor, the actual ARM Cortex, which is within the chipset, and that's the one which is the root of trust for the whole attestation for AMD Sieve. But as an Ubuntu engineer working on enabling confidential VMs for Azure, I have to worry about a higher level form of attestation. So an attestation which also includes the boot process, making sure that the VM has booted correctly, and also which includes guarantees over the security of at rest for the confidential VM. So for somebody who is consuming a confidential VM on Azure, it is this higher level form of attestation, which is at the end the most important. They want guarantees over the life cycle of the VM. But I understand at the core of it, of course, if the silicon architecturally defined remote attestation is not right, if the trust assumptions are wrong, then it doesn't matter how Azure builds its remote attestation or how AWS, because AMD Sieve supposedly is just bad.
Yeah, that's correct. That's the basic motivation for working on these two, because they are providing the base and then the protocols as used by the frameworks on top of any of these solutions. So that's why it's a separate category. But you are exactly correct, and that's also our observation, that if you starting from the base, if the base is wrong, I mean, anything that you build on top is actually not correct, and that's why one can improve the protocols starting from the ground and actually understand what exactly do they offer. So I mean, we all hear the talks that, okay, so this is confidential computing, and there is a process attestation, which is like a bullet and bulletproof, and this is going to take care of all the things, but this is not correct. We really have to understand what does it protect it against and what it does not, and what are the assumptions there, and then build solutions on top of that, exactly understanding what are the limits of these solutions.
I hear pause. I want to inject real quickly. Time check. So we're halfway through our time, and we have agenda lined up for next time already. And so from my perspective, so the proposal appears very, very broad. And perhaps from a time check perspective and also from an execution perspective, could you possibly pick one item, order it somehow, pick one item to kind of talk through and, you know, let's see if we can get through that. And I think part of getting through that is an understanding of how we measure success, as Keith talked about. And I think another, which we haven't yet bumped into, is how does it map with the charter of this SIG? This charter, as I understand, is, you know, we're not really intending to focus on standards. We're intending to focus on, you know, contributing open source code to the community in some way, shape, or form. So those are the things kind of in my head that are most important to try to get through in the next, you know, 25 minutes is, you know, what is one thing? How do we measure, you know, success? And how does that really relate to what I think this SIG is trying to do, which is create open source code? And if we can just get, and not to say that, you know, everything else doesn't eventually come into scope and talk about and so on, but if we just leave this meeting without, you know, still in progress, we're probably not going to get back to it for a bit because there are other agenda items coming up. So.
Sure. So then I will quickly go back to the second part of the second goal, so to say, and that was basically that how we can analyze and categorize the claims, and the coding part, as you talked about, I forgot the word, what's called, it's the regulations of so what do you have, the regulations for the SIG?
I'm sorry.
Charter, yes, exactly.
Charter,
sorry.
yeah.
So according to the charter, you need the open source code, and that basically links to that charter part, which is we can have or we actually want to have the generic formalism with which one can define the claims precisely and then categorize them, like, let's say, the measurement, runtime, and static time. What does it exactly mean, and what how we can categorize it into the different all these claims into different categories. So this is the kind of goal for all of the trusted execution and all of the categories. And yeah, so I will show one example that what we mean by runtime measurement is not precisely understood by all of them in all of the community in the same way. So that's the kind of thing. Coming back to the approach quickly, I just want to talk about the three phases. And as I said, so the provisioning phase, initialization, attestation, protocol, and trustworthy operations. So they are in the increasing frequency order. Provisioning, at the start, it can be a certificate in case of Intel, for example, PCK certificate. And initialization, the first, the few steps which are not repeated every time an attestation is required, they are part of the initialization phase. And the attestation protocol, including what is done, the protocol which is run every time an attestation is sent over. So that basically constitutes that attestation protocol as named here. And then what is coming more to measuring the success, so or towards what really we mean by each of the phase and what should be defined in each of the phases, let's say. So we have three categories or three different steps to think about the attestation mechanism or the attestation protocol: the generation of the remote evidence, appraisal of the remote evidence, and then the appraisal of attestation results. And in the generation of remote evidence, one should really talk about what are the KDFs of the keys which are generated and used there. Coming back to the point which one of you mentioned, I forgot the name, Ijlal maybe, that the architectures solutions, so how the keys are generated, and from there we can understand what is the constant thing, how we can, what attacks are possible and what not. And then the formats in which this is communicated, this relates to the standards and how we can standardize them so that interoperability is possible. And then the endorsements, reference values, and appraisal policy for remote evidence for the appraisal as defined in the RATS architecture, the same. And then finally, the appraisal for the attestation results. Now, this is coming back to the point on refinements. What exactly do we define? So this part is almost the same as the RATS, except that we have an attestation request coming from the relying party, attestation challenge generated by the verifier, and we have an additional entity, and this relates to what can be done for the standards or what can be defined or what exactly I mean by the refinement, which is namely this identity supplier providing an identity to the attester included as part of the attestation itself. And as I said, the local versus remote part for Intel specifically, local attestation is a part or necessary part. One cannot generate a remote evidence directly. It's really a part, integral part of the thing. And one cannot really talk about remote attestation architecture without having talk about the local. That's why we distinguish between local and remote inside the terminology. And this is one example of what terminology refinement could mean. So if it's on the same platform, it's going to be local, and if it's on a different platform, it's going to be called as remote. So we have like these prefixes attached to, let's say we talk about local evidence or a remote evidence. So as a prefix, this will be attached to be precise what we are really talking about. And similarly, the verifying relying party model, where both of them can be combined from verification perspective, it's easy to verify them. So I can go through one example quickly, or otherwise I can just answer the questions based on this and see if there is any feedback on that. So measuring the success specifically for this, as I said, would be that I have one solution, let's say Intel TTX, which is already done, mapped to this attestation architecture. And another solution in the same category, let's say we have IBM PEF, and we map it to the same architecture and see if everything is clear, let's say from the vendor side or from the RATS architecture point of view, or let's say our this refined architecture, or if something needs to be changed or refined or described more precisely. So that would be.
Excuse me. So yeah, what is the result of this? Is this a document describing the mapping?
So by result, you mean what the SIG would come up with? It could be, I mean,
we said we have to define a mapping, right? And that seemed to be the activity. So I'm asking, what is the result of that activity? We define a mapping. How do we capture the mapping? I assume we want to capture it. It's not just we define it, we speak the words and then walk away.
Okay. So, I mean, I'm from academia. I would be interested in papers, but we can do it like it would be, papers would be available free of cost for everyone. So just like the paper quoted in the, how to say this, was. So
you're proposing activity for this SIG, I think. So I think it's important for the SIG to understand what is produced, right?
So that's how academic paper, or is a research paper not a useful outcome for the SIG, or what exactly did you mean?
I'm speaking from the context of you're pitching a project for the SIG, right? You put in an issue in GitHub. Now you're talking about some of the details. And at this point in the conversation, you're saying, okay, for this topic, you said we're going to define a mapping. So I'm asking, how do we, you know, what is produced from that? And I think you're saying, from your perspective, a research paper document would be great. And whether that maps to what this SIG does, or so or not is I think for this SIG to define. My understanding, I joined in flight, so I wasn't around when it was formed. But from what I can gather, this SIG seems to be focused on thinking about writing open source code versus writing research papers or documents. But
I mean the code that was mentioned here would then be open source inside the one of the repos, just like the other proposals were. So
no, but I'm
mean,
going back to,
that's-
I'm trying to stay very specific, right? So you're talking, the example you're giving was mapping, I think, TDX and one other flow
let's say,
to the architecture. And so if that's the activity, the result seems to be a document. I'm not seeing where code plays into this.
Okay.
Is it fair to say that we're missing on the formal verification part, that Mohammed is going to actually verify the protocol? So that's a lot of deep scientific work. It's not a Word document that maps the parts out.
So maybe I can answer it in two ways, and you can help me on the way if I'm not understanding it. So there are two parts as I have, that is, one is refinement and then formal specification and analysis, right? So there will be two outcomes of the whole effort, let's say, or the proposal. That would be, one would be a mapping or a refined attestation architecture. Let's say that would be something, let's say this plus something added on top, maybe that would directly go to the standards. Let's say update of RATS architecture or whatever the procedure is, or a new something. I'm not familiar with all these technical terms. Anyway, so this really feeds to the RATS architecture. And then we have formal specification and analysis, which has a scientific value. And this document can be a research paper, right? So it can be, it's a useful activity, and it gives us more guarantees. Let's say that the protocol is useful in the real world scenarios, and what are the assumptions, to understand better what are the assumptions. So this could be also taken up inside the, according to the charter, which requires a coding part. So this would be an open source contribution to the SIG repos. So I think it has then both parts, which is the your question maybe.
I think you were underselling your proposal, because obviously the biggest contribution is that you would formally verify the remote attestation protocols, with the caveat that are not verifying the end user, if I may call it so, remote attestation protocol. You're verifying the runtime silicon tied attestation protocol for the different the different silicon TE solutions we have. And obviously in the security world, extremely important. I mean, cryptographic protocols, we trust them a lot because we have been able to formally verify them. We have, at least in cryptography, we're able to provide those formal guarantees. So if you can have a strong formal verification of these runtime remote attestation, is extremely valuable. What you were saying about it being a research paper, or you just publish it on your personal website, that's just like the cherry on the top. It doesn't matter, as long as we have that formal verification, people can then take it. Why I see this important is that Azure can take your work and expand on it to produce a formal verification for their own remote attestation flow for CVMs, for AMDC, whatever.
Yeah, exactly. So this is this will kind of provide these primitives which others can also use. So I mean, from my perspective, a research paper is quite a valuable thing, and others can, of course, then use that. And if the CCC repo has all the code, so everybody is basically can utilize it to their benefit. And I don't, so of course, like that research paper would be kind of the document outcome, or if you like, you can have it on the SIG repo also as one of the documents, or whatever you would like to have. But I mean, for me, research paper which is reviewed by the experts in the field of security and formal verification would be quite a valuable thing, instead of just, let's say, the few of us just talking and coming up with some documents. So that would be quite a valuable contribution, in my opinion.
So in one of our other proposals for the SIG, there was the attested TLS proof of concept, and it also included formal verification. But I think it would probably be verification of the higher level protocol, taking assumptions on the properties of the actual attestation mechanism. And what you're proposing here is to actually have a verification that those properties are actually held in each of the types of TEs. Is that accurate?
Yeah, that's actually correct. Yeah.
Yeah, it seems like the TLS formal verification would have abstracted away the,
Right.
how the underlying, what are the trust assumptions, and this work might potentially complete it. Having said that, the most useful or direct beneficiary of such work would be potentially people who have to decide between which silicon technology to go for, and perhaps they will find that TJX is more secure than, I don't know, AMD or the upcoming ARM silicon provider technology. But also, Mohammed, you have also to look at it from, I would say, my perspective at least. I work on the kernel level enablement, and what I care about the end remote attestation, the life cycle remote attestation being correct, and that includes what I would like to, for my own sanity, refer to as runtime attestation, which is what I think you are talking about. That's only one component. So the end user or the end remote attestation is, yes, what you're talking about, runtime, but it's boot remote attestation and it's at-rest remote attestation. And as you know, security is not composable. So there will still be a need for somebody to take all these components and formally verify the end protocol for the end remote attestation. So this would be one piece to get there, an important piece, but it still remains one piece.
Could we possibly the formal verification thing is making it concrete and much more understandable for me. Could we possibly is it possible to turn the proposal into, to leave the existing proposal, but to pick the first formal verification, just one, so I can simply rationalize about it, and say, this is, maybe this overall thing is 12 formal verifications, but what's the first one? And could we talk about that and agree? Yes, it's in the charter, no, it's not, and things like that, and that's what makes sense to me. There seems to be so much here. It's almost, well, it's not quite open-ended, but it's very large. But that's just my thoughts. I mean, if folks want to kind of go with the,
So just to clarify, in our work with Thomas and Simon, we have basically kind of completed this one already, and the three categories, we already have the instantiations of one prominent solution, and so I mean, we can already take 1.5 of 5 of them, and the coding part, of course, is already there. And for provisioning, we don't have, but this, so I mean, I can already take 2.5 of them. So we need one more solutions in order to be sure that what we are saying, let's say, in this is already helpful for other solutions which are very different from these solutions. So to cover the whole spectrum of the different solutions, because I know that IBM PF is different from what InterTDX implements, and therefore we would like to also have some variety among them.
Is
so
it
if
fair
you like
to
to have
is it fair to say that you are not building whatever 12, 14 formal verifications? You're building a framework to formally verify ideally any remote attestation protocol, which is why you care a lot about having this these protocols mapped specifically to the flow you have showed, because you basically will code one formal verification, maybe using ProVerif, and ideally it should accommodate all existing remote attestation protocols and all future ones if you can map them to your diagram.
Yeah, that's actually correct. So that's the basic aim of having to this specific architecture, that we have the high level mappings of the whole thing in ProVerif. ideally one, but at the moment we have 3 of them in 3 different categories, which can then be mapped to some other in the same category. I mean, the one we have for scone can at the moment just be generalized to Grameen and someone else which is in this category close enough. But we need to generalize it further. And I would say if all of them can be mapped to one proverif lemmas or one proverif generalization, that would be ideally great, but I don't think that would be possible because even within them, they have a lot of variation. And at least if we have still 3 different categories and 3 different mappings possible, everyone maps to that. And somehow we see what are the challenges in these mappings. I would say it's quite a good thing that we do not need to verify each and every, just to give you a maybe some background or context. So we have already spent like 4 years just verifying Intel SGX and Intel TDX. And there the question was, or the research kind of question is, should we go, and every year we see new trusted execution environments. So how far can we go by verifying just one and each and every trusted execution environment in detail? And there the idea is that, okay, so we cannot really do that. The idea is that to see and compare and contrast what are the differences really from the verification perspective. And there I see the value in this specific goal, and I wouldn't really put it as a background or put it in, I mean, it's an important thing that they all map to one generic thing that we can actually utilize to have the formal specification. Otherwise, one would be lost. I mean, we could create our own, but why not use something which is already there in the form of RATS architecture and have it refined like this and see what are the problems in the mapping to this. So that's why I really want to have this as one of the prerequisites, so to say, of that. And that would greatly simplify the verification task, which would be, okay, so we have this, what are the changes? We implement these changes, the verification is done. And there we compare and contrast. Okay, so this has more trust assumptions as compared to this TEE, and or this has a completely different trust assumptions, and then we might need more verification, proof, lemmas, and so on to work there.
Can I be just a little bit self-serving and suggest that you do, I don't know if you're going to do this work, but if you end up doing this formal verification, I don't see a lot of use, honestly, in formally verifying the frameworks. I think it's much more useful for you to pick, let's say, Azure remote attestation flow, at least as it is described today, and then build on your current proposal to verify that instead. Because potentially a lot of people are going to consume indirectly things from the cloud. They're going to be consuming CVMs from Azure, from Google. So maybe if you want to add it, if you have bandwidth to that, or at least I think it's much more, you will speak to a lot of people's pains if you formally verify the end-to-end flow for a cloud instead of, I don't know, not to undermine it, if you see what I mean.
Yeah, just to clarify, I'm open to ideas, and I'm happy to discuss it further offline sometime. So yeah. we can have, so from user perspective, let's say what is the value that you see there, what are the challenges there, and what thing is missing in what we already have. I would be happy about that. And just for others, if you have any comments that you think would be valuable, closely related to this, I'm of course very open to ideas related to that.
We're 5 minutes from out of time, and okay. From my perspective, I think this is a great conversation. It's very fascinating. I'm learning a lot. An important thing, I think perhaps we can take a litmus test and perhaps make clear for everybody is, so I think it's clear that there's lots of interest in formal verification of different facets of attestation, remote attestation, confidential compute, clouds, this, that, and the other. I'm not sure, in my head, I don't have a clear understanding of whether this group is on the page of we're involved. We think it makes sense for the group to be involved in defining formal verifications, for example, using ProVerif. I suspect the answer is yes, but I haven't heard it concretely kind of acknowledged across the group. So maybe that's one topic we could just briefly kind of do a little straw man poll on, do we think that's in the charter or there's interest? I mean, Thomas, Keith, anybody out there, do you think that this area is something that makes, it's kind of in the charter and makes sense to contribute, collateral for formal proofs?
I think so. And I think that could boil down for this entire proposal's success criteria could be around creating a model for the attestation primitives, that process is secure so that other efforts like the attested TLS could use that as an input so that they can have a more abstracted starting point. And then, if we can map the individual technologies to the assumptions of this model, people can make informed decisions about the different technologies. I think that I believe would be in scope and I think is valuable.
Yeah, +1 here.
Was that, who did I hear? Was that Thomas? Or no?
Sorry, I said +1, yes.
Okay.
What Keith said is, yes, it's basically what I wanted to say as well.
All right. Other folks?
There's Lily on the chat, it says.
Oh, okay, yeah. Really, okay. So it seems like that's that is definitely in scope. Is the group is interested in doing that. So then it sounds largely like being clear what the scope of kind of the formal verification being done by Mohammed by your proposal. And I think it loosely we understand as kind of the lower level primitives, the actual attestation evidence itself, how the different hardware vendors are structuring local attestation, turning it into remote attestation, not the higher level scenarios. That seems like a huge sea of things, but that I think in my head I'm a lot clearer about the value and kind of the direction, what all the pieces are and what part this represents.
Yeah, I definitely see there's a lot of interest. I see it's very interesting. But I do have a question whether this is aligned with the charter. Strictly, like seems my understanding is that the charter of this SIG is to produce a working software, right? So are we here? Yeah, and this the one outcome of this work is more like producing paper, right? So, but I see these are two different issues. Whether we put in the charter or like as a project here, regardless whether we do that, this is an interesting piece of work. I definitely want to see more, more discussion.
Yeah, I would say maybe just in 1 minute. So the coding part is actually according to the charter, and I would say the paper is one of the possible outcomes. So when we do research, we have something as an outcome, and that would be a research paper. So I would so I don't see any problem in having a paper out of what we did as a research or as a coding part. I mean, this formal specification and analysis, the verification part is the code that according to charter meets all requirements. I don't see any problem in that.
And then, so I'm thinking
is more clarification on the charter, because in point B of the charter of mission, we say the scope of the project includes collaborative development under the project license, supporting the mission, including documentation, testing, integration, and the creation of other artifacts that aid the deployment, the development, operation, or adoption of the open source project. So I think in the second bit of the charter, this fits perfectly, right? It's one of the enablers for other things that can be built.
Yeah, so one option I think is that maybe we can bring in, allocate more time in the future there to bring in more in-depth discussion, right? And then we don't, then we can continue to keep in mind, see.
Excuse me, I need to call time. I need to actually head off to another meeting. I'm sure folks will start dropping off. So I don't think we've closed on this proposal, but I think it's definitely, I think, raised awareness that formal verification, perhaps as an ongoing theme and topic for this group is of interest to the group, and it does seem to fit within the charter. So that's where my head's at. And so, but I think I know I'm out of time for this week. So I think we can try out of band to close on Mohammed's proposal. In my head, I think I have enough information to be an intelligent participant in the conversation there out of band. And I propose that we kind of put in a line item for future conversations about to continue to talk about formal verification and different areas in there we see as valuable, attested TLS, other things, cloud service scenarios, things like that. Mechanically, for the next discussion in 2 weeks, we already have, I think Dave and somebody else talking about a Corim or something is lined up.
Dave and Nat.
Dave and Nat, okay. Do we have a volunteer for chair next time around? 2 weeks?
I can do it.
Okay, Shanwei, you got it. Great. Okay, everybody. Thanks for your time today.
Sorry,
Mohammed,
Greg,
thank you
One
for.
more question. So, can you upload this tag?
Sure. I would upload on the SIG.
Okay.
Also, sorry, guys, we continue the discussion on the issue, right? In these 2 weeks.
Yeah, I'm suggesting for me, I was blocked on discussing on the issue because I'd read the paper, but I kind of needed this verbal discussion to get my head around kind of the broader context. So I'm unblocked to kind of, I think, talk on the issue and, and come to closure.
Yeah, I was in the same place. I think we can clean up the proposal some to get more focused on what the outcome should be. And I think we continue the discussion there.
Also, Usama, probably there are two things conflated. So if you split the two proposals into two separate issues, then we can have, this would be great in terms of cleanup of the issue. Because, yeah. Cool.
Great. Yeah, let's take that offline.
Yeah.
I got to drop now. So
Yeah,
thanks,
bye-bye.
everybody. Have a good couple
Bye,
of weeks.
everyone.
Okay, bye.
Thank you. Bye.